Imagine a submarine that never needs to surface for fuel or air. Picture an African-built vessel gliding silently through the deepest oceans, powered not by diesel, not by nuclear reactors, but by infinite clean energy that never runs out. This is the story of Africa's self-powered submarine, a groundbreaking machine that redefines how humanity thinks about underwater exploration. For decades, submarines have been symbols of military power, scientific curiosity, and technological prestige, but they have always been shackled by limitations. Diesel-electric submarines must surface or use snorkels regularly to recharge batteries, making them vulnerable and limited in range. Nuclear-powered submarines solved that problem, but they brought radiation risks, massive costs, and geopolitical suspicion. Now, Africa has unveiled something entirely new, something the world never imagined would come from a continent often underestimated in technology. This submarine runs on clean, infinite energy, allowing it to stay submerged for years without surfacing. It moves silently, blending into the vast blue wilderness of the oceans with no heat signature, no fuel trails, and no pollution. The ocean, covering more than 70% of the planet, has always been mysterious and dangerous, but with this technology, Africa positions itself as the new pioneer of the deep sea. Scientists, explorers, and even military strategists are stunned at the possibilities of this vessel. For the first time, humanity can contemplate long-term deep-sea missions without worrying about resupply or safety risks from radiation. This is not a fantasy or a science fiction tale. It is a technological revolution born from innovation, necessity, and vision. The submarine's energy source is based on the same principles that power Africa's rising fleet of self-powered cars, buses, and even aircraft. At its core is a system that draws, harnesses, and recycles energy without external input, a technology dismissed by many as impossible until Africa began proving it with working machines. The self-powered submarine takes this innovation further, packaging it into a vessel capable of surviving crushing pressures thousands of meters under the sea. The development began in secret in a coastal African nation determined to leapfrog beyond traditional energy systems. Engineers and innovators collaborated with marine experts, studying how to design a hull that could withstand the abyss while still housing the new infinite energy system. The result is a submarine unlike any other ever built. Its sleek shape is optimized for hydrodynamics, reducing drag as it glides silently beneath the waves. Its power system emits no noise, no radiation, and no exhaust, making it undetectable by traditional sonar systems. This has immediate implications not just for science, but for defense, security, and geopolitics. Navies around the world rely on sonar to track submarines, but an energy source that produces no signature changes the game entirely. Africa now has a vessel that can remain hidden, operate indefinitely, and travel farther than any submarine before it. But beyond military use, the promise of this submarine lies in exploration. The deep ocean is still largely unknown, with more secrets than the surface of the moon. Less than 20% of the seafloor has been mapped in high detail, leaving vast regions of mystery. What ecosystems exist in the dark trenches thousands of meters below? What minerals and rare earths lie undiscovered beneath the seabed? What unknown species thrive in conditions of pressure and darkness that human technology has rarely reached? The African self-powered submarine could answer these questions. Because it never needs to resurface, it can spend months or even years mapping, exploring, and studying the deep ocean. It can carry scientific labs on board, allowing researchers to conduct experiments in real time while submerged. It can deploy autonomous drones that swim farther into narrow crevices, relaying data back to the vessel. It can monitor tectonic plate movements, ocean currents, and ecosystems in ways never before possible. In a world increasingly dependent on ocean resources and concerned about climate change, such capabilities are invaluable. Imagine a submarine stationed permanently under the Arctic ice, tracking changes in ice sheets, monitoring temperatures, and studying ecosystems affected by global warming. Imagine another stationed near hydrothermal vents, documenting species that survive in boiling mineral-rich waters, expanding human understanding of biology and evolution. Imagine one deployed for mineral surveys in the deep-sea crust, potentially unlocking new sources of cobalt, nickel, and rare earth elements critical for technology. These are no longer just dreams, they are real possibilities with the African self-powered submarine. The story begins with the decision to reject dependency on foreign technologies and chart a new course in marine engineering. Africa's innovators asked, what if submarines could be free of the limits that plagued traditional vessels? They knew that energy was the key. Without fuel limits, a submarine becomes a permanent underwater station. Without noise and heat, it becomes invisible to surveillance. Without pollution, it becomes environmentally sustainable. The infinite clean energy system that powers the submarine is compact, modular, and scalable. It does not require massive nuclear reactors or hazardous fuel storage. It does not need complex refueling infrastructure or costly supply chains. Instead, it continuously generates and recycles energy within itself, creating a loop that sustains operations indefinitely. Engineers adapted this system to the marine environment by encasing it in pressure-resistant modules that could survive the crushing weight of the deep. They integrated it with advanced propulsion systems that are magnetically driven, producing thrust without mechanical noise. The result is propulsion so silent that marine animals are barely disturbed when the submarine passes by. This reduces ecological impact while improving stealth. Onboard systems are equally revolutionary.
The submarine features life support systems capable of recycling air and water for decades. Carbon dioxide scrubbers, powered by the infinite energy source, ensure breathable air at all times. Water purification systems convert seawater into fresh water for the crew. Hydroponic farms provide food, making long missions possible without external supply.
The vessel essentially becomes a self-sustaining underwater habitat. Crews can live in comfort while exploring, researching, or monitoring the deep sea. The technology allows for missions of unprecedented length, redefining what submarines can achieve. When the project was first announced, many global powers dismissed it as a publicity stunt. They doubted Africa had the capacity to design, fund, and build such an advanced submarine. But skepticism turned to shock when footage emerged of the vessel in operation. It dove beneath the waves and did not return for months. When it resurfaced, it had traveled thousands of kilometers, mapped unknown seafloor, and returned with data that stunned scientists. The proof was undeniable. Africa had built a self-powered submarine, and the world could no longer ignore it. International reaction was immediate and mixed. Scientists celebrated, seeing in it the dawn of a new era in ocean research. Environmentalists praised the clean, sustainable energy system and the lack of pollution. Navies, however, grew nervous. The ability to move silently and indefinitely underwater challenged global military balance. For Africa, it was both an achievement and a responsibility. The submarine demonstrated that innovation knows no borders, that the future of technology can be shaped from anywhere. It also showed that Africa was no longer just a consumer of technology, but a leader in creating it. The submarine became a symbol of sovereignty, resilience, and vision. It inspired young engineers, scientists, and dreamers across the continent to believe in what was possible. It proved that Africa could not only catch up with the world, but surpass it in fields once thought unattainable. And this is only the beginning. The submarine's maiden voyage was kept secret at first, known only to a small circle of engineers, scientists, and naval officers who had dedicated years to the project. They watched anxiously as the vessel descended into the depths, its hull groaning against the first test of pressure. Inside, the crew reported silence, stability, and power levels holding steady without fluctuation. Days turned into weeks, and still the submarine did not need to surface. it became clear that something extraordinary had been achieved. When the vessel finally returned to port, it carried with it high-resolution maps of the ocean floor, samples from depths previously unreachable, and biological discoveries that shook marine science. The submarine had encountered entire ecosystems around deep hydrothermal vents, creatures glowing with bioluminescence, and unknown microbial colonies thriving in conditions previously thought impossible for life. These findings alone justified the project as a scientific triumph. But beyond science, the very fact of the submarine's endurance was historic. Global defense analysts quietly admitted that Africa now possessed a capability rivaling, if not surpassing, the world's most advanced naval powers. This revelation sent shockwaves through capitals in Washington, Beijing, Moscow, and beyond. How had a continent underestimated for so long suddenly leapt ahead in one of the most complex fields of engineering?
The answer lay in Africa's approach. Rather than replicating the old models of power, Africa created something entirely new. The self-powered energy system removed the most expensive and limiting factor of submarines. Instead of trying to master nuclear propulsion with its decades of risks, Africa invented a technology that bypassed the need for it altogether. This was the brilliance of innovation born not from abundance, but from necessity. Lacking massive nuclear budgets, Africa turned instead to clean, infinite energy, something the rest of the world dismissed until it became reality. The submarine became a symbol of that philosophy, leapfrogging outdated systems and going straight to the future. On board, the design reflected a marriage of efficiency and ingenuity. The interior was modular, allowing it to be reconfigured for scientific missions, defense patrols, or even humanitarian roles. A single submarine could function as a mobile ocean lab, a defense outpost, or a rescue vessel. The control systems were streamlined, relying heavily on AI-assisted navigation and monitoring. This reduced the need for large crews, making the submarine easier to operate and safer in emergencies. Even the living quarters were designed with sustainability in mind. Recycled materials, hydroponic food systems, and waste-to-energy converters created a closed-loop environment. Every system on board demonstrated the same principle: independence from the surface world. This independence gave rise to new possibilities beyond what submarines had ever been imagined to achieve. Some scientists proposed using them as permanent research colonies, stationed in the deepest parts of the ocean. Others imagined fleets of such submarines creating a global monitoring network for seismic activity, climate change, and biodiversity. For defense, the implications were even greater. A submarine that could stay underwater indefinitely, moving silently and unpredictably, could not be tracked by conventional means. This meant Africa now had the potential to control vast areas of ocean with just a few vessels. Global navies began to rethink their strategies, wondering how to counter a force that could not be detected. But the African innovators behind the project insisted that the true purpose was exploration and preservation, not war. They emphasized the role of the submarine as a tool to understand and protect the ocean. Indeed, one of the first official missions after the maiden voyage was dedicated to studying coral reef systems under threat from warming waters. The submarine documented bleaching events, tracked fish populations, and transmitted real-time data to universities around the world. For the first time, African scientists were leading global marine research. This role reversal, Africa not just receiving aid or knowledge but producing it, was groundbreaking. It changed perceptions both within the continent and abroad. Young students who watched the broadcasts from the submarine began to see themselves as future oceanographers, engineers, or explorers. The sense of pride spread rapidly, and with it, a wave of curiosity about science and technology. At the same time, corporations and governments from abroad began seeking partnerships. Some wanted access to the submarine's mapping data, which held potential clues about valuable mineral deposits. Others wanted to understand the energy system itself, hoped to adapt it for their own industries. Africa found itself in a powerful new position, holding technology that the world desperately wanted. This opened doors to negotiations, trade deals, and collaborations that had previously been one-sided.
For once, Africa was not the consumer but the provider, not the student but the teacher. The self-powered submarine had shifted the global balance of technological respect. Yet, with such power came challenges. There were debates within Africa about how best to use the submarine. Should it be shared openly with the world or guarded as a strategic asset? Should it focus on science and exploration or also on defense and security? Some argued that secrecy was essential to protect the technology from exploitation. Others believed that transparency would build trust and avoid an arms race.
Ultimately, a compromise was reached. Africa would lead global scientific missions with the submarine while keeping its energy core technology confidential. This decision proved wise, as it positioned Africa as a leader in ocean research while avoiding immediate military escalation.
International teams of scientists were invited on board, experiencing firsthand the capabilities of the vessel. They marveled at the silence, the endurance, and the comfort of life under the sea. They also witnessed discoveries that changed their fields forever. Marine biologists cataloged hundreds of new species. Geologists analyzed samples that hinted at vast, untapped mineral wealth. Climatologists tracked deep-sea currents that influenced weather patterns across continents. Every mission brought back new knowledge, and with it, greater respect for Africa's role. Meanwhile, the engineers who had built the submarine continued refining it. They experimented with new hull materials that could go deeper, withstand greater pressure, and reduce drag further. They tested advanced AI systems to allow partial automation, reducing the need for human intervention. They integrated communication relays capable of sending data to satellites even from the ocean floor. Step by step, the submarine evolved into not just a machine, but a platform for continuous innovation. It became clear that this was not a one-time achievement, but the beginning of a new era. Other nations scrambled to respond, but replicating the system proved difficult. Without access to the self-powered energy core, attempts to build equivalents stalled. Billions were spent by advanced nations, but the results lagged behind Africa's proven model. This only increased the fascination with how Africa had done it. Was it genius, luck, or both? The truth was simpler. It was the product of vision, persistence, and belief in possibilities others had dismissed. For generations, Africa had been told it was behind in science and technology. Now, through the submarine, it showed that leadership could come from anywhere. And as the submarine dived again into the deep, the world watched with a mixture of awe, envy, and anticipation. The oceans had always been the final frontier of Earth, and Africa had claimed the key to unlocking them. With every mission the submarine undertook, Africa's confidence grew stronger. The crew that manned the vessel became pioneers, not just sailors, but explorers of a realm where few humans had ever gone. They were trained to operate advanced systems, interpret scientific data, and maintain the revolutionary energy core that kept the submarine alive. Life aboard the vessel was unlike anything on land. There was no sunrise, no sunset, only the soft glow of artificial lighting within the pressure-resistant hull. The silence of the deep ocean surrounded them, broken only by the faint hum of the vessel's systems. Occasionally, distant whale songs or the crackling of shrimp fields echoed through the water, reminding the crew they were never alone in the ocean's vastness. Meals came from hydroponic farms and nutrient-rich rations produced directly on board, making the submarine self-sufficient. Fresh water was drawn from the sea and purified endlessly, providing comfort even in the darkest depths. For recreation, the crew watched films, exercised in compact gyms, or gazed through reinforced observation windows at the alien world outside. They saw creatures no one had ever documented before, jellyfish that pulsed with rainbow lights, colossal squid drifting silently, and translucent fish with organs glowing like lanterns. Each sighting reminded them why they were there, to unlock the mysteries of the ocean. But the longer missions also tested their endurance. Months underwater without surfacing created psychological challenges even with AI-assisted mental health systems in place. The crew had to rely on one another, building trust and resilience in ways that bonded them like family.
This resilience mirrored Africa's own journey, a continent underestimated but capable of enduring and rising stronger. Each voyage was not just exploration of the sea, but proof of Africa's resilience in the face of doubt. As missions expanded, so did international attention. Scientific journals filled with articles citing data collected by the submarine. Marine biology departments around the world began restructuring research programs to align with Africa's discoveries. Suddenly, African scientists were keynote speakers at global conferences, presenting findings from the deep ocean. For the first time, Africa was setting the scientific agenda, not following it. This shift unsettled some traditional powers. For decades, they had dominated oceanography, deep-sea mining research, and military submarine development. Now, their leadership was being challenged by a technology they did not invent and could not yet replicate. Diplomatic visits to African nations increased dramatically, as leaders sought partnerships or at least access to submarine missions. Some offered funding, others promised trade deals, and a few issued veiled threats if excluded. But Africa held firm, determined to use its submarine on its own terms. It refused to sell the core energy system, knowing that to give it away would be to lose its unique advantage. Instead, Africa offered collaboration, joint research missions, data sharing, and global partnerships under African leadership. This model was revolutionary in itself, reversing centuries of imbalance in international relations. For once, Africa was not pressured into dependency, but setting conditions for cooperation. The submarine was not only rewriting science and defense, it was rewriting diplomacy. Meanwhile, the vessel's capabilities continued to expand. Engineers introduced modular pods that could detach and operate independently for weeks at a time. These pods carried specialized equipment for mapping trenches, studying marine life, or even conducting undersea construction. Some envisioned using them to build permanent underwater stations, with the submarine serving as a mothership. Others suggested they could repair undersea internet cables or monitor pipelines, giving Africa strategic control over vital infrastructure. Every improvement turned the submarine from a vessel into a platform capable of countless missions. Its silence and independence meant it could linger near any coastline, undetected, for as long as necessary. For navies used to monitoring ocean traffic, this was deeply unsettling. Reports emerged of global powers increasing sonar sweeps and investing billions in next-generation detection systems. Yet none could reliably detect the African submarine once it submerged. This imbalance created whispers of a new era of undersea strategy, one no longer dominated by nuclear superpowers but by a clean energy pioneer.
But while some viewed it through the lens of conflict, others saw hope. Environmental organizations hailed the submarine as a breakthrough in sustainable ocean research. Unlike noisy diesel or nuclear vessels, it left no trail, emitted no radiation, and disturbed ecosystems minimally. For once, exploration could proceed without destroying what it studied. This harmony with nature became part of the submarine's identity. It wasn't just a machine, it was a guardian of the ocean. The crew felt this deeply as they drifted past coral reefs glowing with fragile beauty, schools of fish scattering before their silent passage, and the leviathans of the deep gliding peacefully nearby. They felt connected not only to the mission but to the ocean itself, as if technology and nature had finally found balance. This philosophy resonated across Africa, a continent where harmony with the land and sea has always been part of culture. The submarine became more than a vessel, it became a story of identity, progress, and destiny. Schools began teaching children about ocean exploration as part of African heritage. Documentaries aired footage from onboard cameras, showing people across the continent the wonders hidden beneath the sea. It ignited imagination in ways never before seen. Children in villages far from the coast dreamed of becoming oceanographers or submarine pilots. Universities launched new marine research programs, training the next generation of scientists and engineers. Africa was not just consuming technology, it was cultivating a future defined by it. And the submarine was the spark. At the same time, rumors spread of new prototypes being built. Some claimed Africa was developing a larger submarine capable of housing hundreds of people and functioning as an underwater city. Others whispered about smaller drones, swarms of autonomous mini-subs powered by the same infinite energy system. Whether true or not, the speculation alone kept the world on edge. Everyone wanted to know, what would Africa do next? In the deep ocean, the possibilities were limitless. Each mission opened new doors, each discovery led to more questions. Could the submarine unlock the secrets of ancient shipwrecks resting at the bottom of the sea? Could it monitor volcanic activity beneath the waves, predicting eruptions and tsunamis before they struck? Could it serve as a bridge to space exploration, training humans to live in isolated, self-sufficient environments? The submarine was not just changing how humanity viewed the sea, it was changing how humanity viewed its own future. And through it all, Africa stood at the center, steering the course of this revolution. The ocean is vast, mysterious, and powerful, and for centuries it has guarded its secrets against human curiosity. Now Africa held the key to those secrets in the form of a silent vessel that could stay submerged indefinitely. With every dive, the submarine's crew brought back glimpses of worlds hidden from human eyes. They filmed towering undersea mountains, deeper and taller than the Himalayas, shrouded in eternal darkness. They discovered entire valleys lit only by the glow of bioluminescent organisms, creating alien landscapes that defied imagination. They listened to the chorus of the deep, whales communicating across thousands of kilometers, dolphins navigating unseen, and strange unclassified sounds hinting at creatures still undiscovered. Each discovery added to the sense of awe, but also responsibility. The ocean was fragile, and human interference had already damaged coral reefs, fisheries, and coastal ecosystems.
The African submarine, with its clean energy and silent propulsion, proved that exploration could be different. It did not burn fuel or spill oil. It did not disturb wildlife with constant noise. It did not release radiation into the water. It was a vessel designed for harmony, not conquest. This philosophy guided its missions and earned it respect worldwide.
But respect was not the only reaction, it was also fear. Military analysts struggled to understand how Africa had achieved what they considered impossible. They had invested billions into nuclear fleets, yet here was a vessel from Africa that surpassed their endurance without the dangers of uranium. Speculation spread about the submarine's true capabilities. Could it launch weapons from the depths? Could it sabotage undersea cables or pipelines undetected? Could it monitor coastlines without ever being found? These questions kept admirals awake at night, knowing their fleets were suddenly vulnerable. Some nations called for restrictions on Africa's submarine program, comparing it to nuclear non-proliferation. But others quietly sought to form alliances, hoping to share in the benefits of the technology. For Africa, this was a defining moment. The submarine had given the continent leverage in global politics, something it had rarely possessed before. But it also carried a heavy burden: how to wield this power responsibly.
African leaders met in long conferences, debating strategies and future plans. Some argued for expanding the fleet rapidly, establishing dominance over the oceans. Others pushed for restraint, focusing on science and diplomacy. Ultimately, a balanced path was chosen: build a few more submarines, but dedicate them to exploration and shared scientific missions.
This approach kept global tensions lower while showcasing Africa's role as a responsible innovator. And so the submarine became not just a vessel, but a symbol of leadership. Each mission was broadcast in part to the public, with cameras capturing breathtaking underwater scenes. The world watched as the submarine drifted past undersea cliffs higher than skyscrapers, filmed giant tube worms clustered around volcanic vents, and documented fragile jellyfish glowing like galaxies. These images captured the imagination of millions, sparking a new global fascination with the deep ocean. But what set this apart was that it was Africa bringing these images to the world. For the first time, documentaries narrated by African scientists were being aired on major networks. For the first time, African explorers were household names admired by children in countries far beyond their own. The psychological impact was immense. Africa was no longer just a story of poverty, struggle, or conflict. It was a story of innovation, discovery, and leadership. This transformation mattered as much as the technology itself. It shifted the narrative of a continent long underestimated. But the missions also revealed dangers hidden in the depths. The submarine encountered massive undersea landslides capable of generating tsunamis. It measured methane hydrates, frozen gas deposits that, if destabilized, could accelerate climate change. It documented plastic waste clogging even the deepest trenches, a sign of human damage reaching everywhere. These discoveries underscored the urgency of protecting the ocean.
The submarine became not only an explorer but also a witness, carrying evidence of humanity's impact back to the surface. Its reports influenced global climate negotiations, adding weight to calls for stricter protections of marine ecosystems. In this way, the African submarine shaped not only science but also global policy.
Meanwhile, work continued on expanding the technology. Smaller unmanned versions of the submarine were tested, designed to explore dangerous or narrow regions without risking human crews. These drones, powered by the same infinite energy system, could map caves, trenches, and volcanic vents for years at a time.
Together, they formed a network of constant observation, feeding data back to the mother submarine.
This created the first true undersea monitoring system, a web of eyes and sensors covering areas humanity had never tracked before. The potential applications were enormous. Natural disasters could be predicted more accurately by monitoring tectonic activity. Fish populations could be tracked, helping prevent overfishing and protecting food supplies. Deep-sea mining companies were forced to reconsider their plans, knowing Africa now had the ability to observe and regulate undersea resource extraction. The balance of power over the oceans had shifted, and at the heart of it was one submarine, powered by an impossible energy source that changed everything. But what truly captured the world's imagination was the promise of the future. If a submarine could run forever without surfacing, what about ships? What about underwater cities? What about spacecraft designed on the same principles? The African submarine was not just a vessel, it was a proof of concept for a new era of technology. And as each mission returned with new data, the whispers grew louder. If Africa could build this, what would it build next?